4.1a, antiderivatives and indefinite integration. In chapters 2 and 3, we took derivatives of things. We kept going forward. We kept going forward. We kept going forward. Now, we're going to start going backward. We're going to start going backward. So I need to kind of like retrain your brain to start going backwards on things. So it's basically taking something and then figuring out if I took a derivative of something before, where did I come from? All right, and so that's what an antiderivative is. All right, all right. So I need to find big F, whose derivative is f of x is equal to 3x squared. So I need to go backwards on this. So what function, if I took a derivative of that function, would give me 3x squared? What function would be that? X cubed. So big F of x is x cubed. Now, is that the only function that could give me a derivative of 3x squared? No. It could be what? X cubed plus 1. I don't want to talk about infinity because that's a direction. But I could say x cubed plus or minus 3. 37 minus 37. Those could all be valid answers. So those aren't good answers to me. And so what is like 1 and 37 and pi? What are those? Those are constants. So my actual answer is going to be f of x, big F of x, is equal to x cubed plus c. All right? And so now I have this constant of integration. And that's where we get here. What we just did is if I take an antiderivative, it's called a general antiderivative, I need to add a constant c. Because do we know what that constant c is? No. Not right now, because we don't have enough information. So let's look at this one. I need to find the general solution of my differential equation, y prime is equal to 2. Now, I personally don't like the notation y prime. How could I notate that? dy dx. Now, truly what's happening is my dx gets moved over to the other side. So I really have dy is equal to 2 dx. Okay, I need to match up my variables. So if I take an antiderivative of this, what is the antiderivative of dy? That would just be what? Y is equal to, what is the antiderivative of 2 with respect to x? No. If I get a slope of 2, what did I take a derivative of?
2x.
2x, exactly. So this is y equals 2x. All right. Oh, I'm sorry. And then we need to put plus c because it's a general.
Yes,
all right.
2x plus c.
So that c could end up being 2. That c could be 0. That c could be negative 1. That c could be 58 billion. I don't know. All right. So that's where we have that c coming in. All right. Pretty good? All right. All right, so now we're going to do these general antiderivatives. So if I have a function f of x is equal to sine x, let's find my antiderivative of sine x. So what could I take a derivative of to get me sine x? Negative cosine. Very good. All right, because what's the derivative of cosine? Negative sine. All right, so it'd be a negative going on. However, what did I forget? Plus c. Very good. All right, let's look at this one. And this is basically going to be our whole lesson today for the most part. So if I have f of x is equal to x to the power of n, and I need to take an antiderivative of it. So I need to go from f of x to big F of x. What do I do to my power?
You divide it by n minus 1.
What do I do to my power first? I need to add 1. So now I have x to the n plus 1. And what do I need to do with it? I need to divide by what? N plus 1. I need to divide it by my new power. Because it's backwards power rule. All right? When I took a derivative of it, what happened to my degree? It came down, right? We multiplied by it. And then what did we do to that power? We subtracted it. So now when we go backwards, we add 1 to my power, and then I divide by it. But because it's an indefinite or an antiderivative of general, we need to add c. All right, let's look at this next one. I have f of x is equal to x to the negative third power.
Oh, I know.
So, what do I need to do to my power, Joseph? I need to add 1 to it, so now I have x to the what?
-2.
-2. Now I divide by what? -2. Now, this is kind of sloppy right here. All right, so we need to kind of make it look a little prettier. And so, we'd end up doing what? Where does this x to the -2 go? Downstairs. So now it's x squared, and then I still have a 2 going on, but then what goes up top? A -1. All right, because I have a negative going on. And so I'd end up with big F of x is equal to -1/2 or -1 over 2x squared plus c. All right, pretty good? All right. All right, so I need to start talking about some terms and notation going on. So when we're solving a differential, my variables have to go together. So my y's will go with dy, my x's will go with dx. All right. Now, here's where I want to spend some time, and I need you to write this down, okay? This is our first time seeing this. Congratulations, we finally made it. So right here, this thing right here is called an integral. All right. It kind of looks like an elongated S almost. All right. That right there is called an integral. What function is inside of it is called your integrand. All right. So I need to go over some vocabulary with you. So you have an integral. What we're taking an integral of is called your integrand. And then this dx is your variable of integration. That's what you have respect to. All right. So it's with respect to x. Remember talking about respecting to when we did implicit? Same kind of concept. All right. So this is with respect to x here. And then the answer to my indefinite integral would be my antiderivative of f of x, which here would be big F of x, and then plus c because we don't know the antiderivative. All right, so it's my plus c, my constant of integration. Now I'd like you to write out another one because sometimes you'll see it this way because we talked about f prime graphs, right? All right, so I want you to write out this: the integral of f prime of x dx. I'm going backwards. So what did I have to take a derivative of to get f prime? Just f of x. So then that answer would be f of x plus c. All right? It's basically saying going backwards one. So let's take this a step further. What if I took the integral of f double prime? What would I get? F prime. All right? It's going backwards, right? So if I took a derivative of f, what do I get? I'm going forward now. If I take a derivative of f, I get f prime. If I take a derivative of f prime, I get f double prime. If I take an antiderivative or an integral of f double, I get back to what? F prime. If I take an integral of f prime, I get to f. And then we have a new one. If I take the integral of f, I get to big F. All right. Now, did you ever take the antiderivative of big F? You'd have to name it something else. All right. Okay. Bigger F. F-U. All right. All right. It's the big C. All right. Just kidding. It'd actually be CX if you took an antiderivative of it. All right. Here we go. So we kind of know all of these already. Okay. All of these are pretty much on your note card already. So if you look at your note card, right now they say f prime on. So if you have like f prime equals secant tan, well, if you go backwards, that would give you what? Secant. All right? So you're just going backwards a level. Now, we will start going backwards of like secant, but right now we're just leaving that alone. Okay? All right, so those will have big F soon, but not yet. All right? There we go. So here we go. We're going to find the antiderivatives of some functions. So this first one we have is 3x. So if I have to find an antiderivative, I'm basically taking an integral of 3x. And who's with respect to? X. So I have the integral of 3x dx. All right, so this x is a power of what right now? 1. So how do we do it? We need to add 1. So now I have x squared. But what do I need to do with it now? Divide by 2. So now what's my coefficient out front? 3 halves. So now I have a 3 halves x squared and then plus c. And then I'm done. All right. So I'm working backwards. All right, here we go. So a lot of the times we need to rewrite our functions. Okay, and some people, their algebra 2 or pre-calc skills kind of lack a little bit, and that's going to cause issues when we start trying to do calculus with it. So if we have an integral of 1 over x cubed, I don't want to think of it that way. Later on you'll be able to, because you'll be able to do it real quick in your head. But right now, when you're first exposed to it, I would really like you to rewrite it. How would I rewrite it? X to the negative third. All right. And so what would you do? After I integrate that, what do I do with my power? I add 1. So now I have x to the negative 2. But then what? I divide by negative 2. But then I kind of want to simplify it up because it's icky right now. So that x to the negative 2 goes where? Basement. And then I'd have a negative 1 up top. All right, pretty good? All right, right now, in your way of thinking, I don't want you to think of it as square root x. What do I want you to think of it as? X to the 1/2, exactly. All right, and so now when we integrate it, this would be an x to the what? 3 halves. But then you divide by what? 3 halves. Now, I don't like you doing that. I don't really like you doing that. I don't think that's a necessary step right there. Instead of dividing by 3 halves, what do you do?
Keep, change, flip.
Golly, stop. What do? Multiply by its reciprocal. So you're multiplying by 2/3. Okay? So I actually think this intermediate step right here is unnecessary. I honestly think you guys are smart enough to just multiply by its reciprocal right there. Okay? So when it's a fraction, multiply by reciprocals. It's so much easier. All right? Keep, change, flip. All right. Pretty good?
It works.
All right, on this one, if I have the integral of 2 sine x, now this one's not that hard with this constant multiple, but a lot of the times when things start getting a little icky, I'll bring a constant multiple out front of my integral. All right. So then you just have to kind of deal with the sine x part. All right, so what's the integral of sine x? Negative cosine. And so then you just simplify it up, so you'd have negative 2 cosine plus c. All right. Again, that one's not that bad, but when they start getting a little bit more complex, bringing out that constant multiple is a little easier. Okay? Pretty good? So rewrite things sometimes before you do it. Actually, I want to talk about one. This one's part of your homework. I think it's number 3. I'm going to just help you out with it. I don't know if I put them exactly correct, but I know the answer will be there. So if the integral of the quantity x minus 4 times the quantity x plus 4 dx. I can't do this yet. What would I have to do first?
Put it together.
I'd have to put it together. And so this is really taking the integral of what? X squared minus 16. All right. So now when I take an antiderivative, this x squared would end up being what? X cubed over 3. And then what's the antiderivative of 16? Negative 16x. And then what do I need to always add? Plus c. All right. Pretty good? All right. So sometimes we need to actually use a little bit of algebra 2 or pre-calc before we even do the calculus. All right, let's keep moving. So here we go. I have the integral of dx. The integral of dx. What's there but it's not shown? A 1. So it's basically, what did I take a derivative of to get 1?
X.
So it'd be x. Plus c. All right, very good. All right, this next one. I have the integral of x plus 2 dx. So what's my antiderivative of x?
X 1/2.
X squared over 2. All right, or 1/2 x squared. I also totally like you doing that. And then what's the antiderivative of 2? 2x. Plus c. Very good. All right. All right, let's look at this next one. I got 3x to the 4th minus 5x squared plus x dx. So what is my new power? It's not x to the 4th anymore, but it's going to be x to the 5th. What would be out front? A 3/5, because I'm dividing by 5. All right. Remember how we bring it down? Now we're dividing by it. All right. So now I have minus. Now I have a new exponent of x to the 3rd. But what's my new coefficient? 5/3. Plus, this is now going to be an x squared over 2. Plus c. All right, pretty good. All right, fantastic. Let's do one more together. So now I need to get back to my function g. And I'm given g prime is equal to 4 sine x plus 2x to the 5th minus square root x all over x. So how do I get from g prime to g? Take an integral. Okay, take an antiderivative. Take an integral of it. All right. But before I do any of that, I need to manipulate the way this looks. I can't work with it right now. All right. Well, I could take out a 4 of sine. That's true. But I'm talking about the fraction thing. What do I have to do first? Like, I literally have to.
Bring an x to the top.
Okay, I can't necessarily bring the x to the top. What do I need to really do with it?
Multiply by x.
Oh my gosh, no. Distribute dividing. Thank you, Gunnar. All right. It just feels weird by saying thank you, Gunnar. I recorded that, by the way. All right. So I need to distribute dividing. All right. So now I kind of think of g prime equal to 4 sine x. And then if I distribute dividing, what's 2x to the 5th over x? 2x to the 4th. And then what's the square root x over x? X to the negative 1/2. Okay. So we should kind of rewrite that before we even take an integral of it. All right. So now I need to get back to g. So I'm taking an integral with respect to x of both of them.
What about the x's on the bottom?
I don't have it anymore.
No, you're dividing.
I distributed dividing by x. He's special. All right, here we go. So now let's take an integral. So what is the antiderivative of 4 sine x?
Negative 4 cosine.
Negative 4 cosine. And then what is my antiderivative of 2x to the 4th? What do I need to do with my power? I add 1, so now I have x to the 5th. But then what's my new coefficient? 2/5. All right. And then this one trips people up at first. Now my new power is what?
1/2.
X to the 1/2. And I divide by it, right? No, don't do that. Multiply by its what? Reciprocal. So I'm multiplying by what? 2. So I have minus 2 x to the 1/2. And then what? Plus c. So my g of x equation is that. All right. Now, how could you check all of these? Take a derivative of it and see if you get what you started with. All right? That's exactly what you could do. All right? Pretty good? All right. All right, there we go. They're all odd problems. They're all odd problems.